Newton's law of cooling states that the temperature T of an object decreases exponentially as a function of time T, according to the equation T equals T to the basically room rate plus T the initial starting time minus T room rate e to the minus RT, where say T sub O is the initial temperature of liquid and TR is the surrounding temperature, and R is the liquid's rate of cooling. So the first thing we need to find is we want to find if a cup of coffee with an initial temperature of 180 degrees is placed in a room with a temperature of 70 degrees and coffee cools to 140 after 10 minutes, find R. Well, I'm going to tell you what. Let's go up here. Let's kind of simplify some of our stuff and color some things in and plug it in. Well, the 140 is the amount. I want to know how long it takes to get to 140. Room temperature is 70. I started at 180, and we're doing it for 10 minutes. So this will help me find the rate. So basically 180 minus 70 is 110. I'm going to minus 70 from each side. Then I'm going to divide by 110. I get this nice decimal. You can make it 70/11ths if you want, but I like that better for this here. Now how do I get rid of the E with ln? Get rid of E with ln. So it's going to cross that out. But then I find that, just go to my calculator, type in ln into that. Then right there, and I get this negative 0.541 divided by negative 10 means that the E, or the rate, is 0.045. So the rate is 0.045. So now I'm going to use this R to determine the temperature of the coffee. All right? So now I want to go back up here and kind of plug in the same numbers, except this time I know the R and I know the time, so I'm just going to plug it all in to get an answer for what the total time is. Well, that part's still the same. Take this negative 0.0.5 times 20 is negative 0.9. E to the negative 0.9 times 100 is that, added to the 70s, 114.72 degrees. So after 20 minutes, that's how hot the temperature is still going to be. Woo, Nelly, it's still pretty warm. So how long will it take the temperature to reach 75 degrees? Well, so I'm going to go back to the same numbers, because at this time I want to find how long it'll take to reach 75 degrees. That's what I'm looking for. Still same 110, minus 70 again. Divide by 110. And kind of before, how do I get rid of E? With ln. So I'm going to get rid of that E with ln. So I'm taking the ln of that right there. Cancel that one out. I get this negative 0.390914 divided by this negative 0.045. So basically I get 68, just a little over 68 minutes for the temperature of the coffee to reach 75 degrees.